data values of A and B from the registers and it will process the instruction, right? So whenever you want to execute any instruction, the CPU requires the required data, and that data will be retrieved from your register, right? Whatever the data, whatever the instruction you are executing at present, that data will be there in your register. Once that instruction, suppose if you are done with the instruction C equal to A plus B, your task is done, then no need to store the values of A and B in the register. You may replace A and B with some other data values, whatever is required at that time, right? That is the reason we are calling it as a temporary storage device. And whatever the instruction you want to execute at present, that data will be placed in the register. So your CPU mainly contains three components. One is the ALU, arithmetic logic unit. It is used to perform your arithmetic operations. And the second one is control unit. I'll explain what is this control unit and the different types of register. Right? So the three main components of your CPU are the ALU, control unit, and different types of register. What are the different types of registers in your system? There exist mostly, the most commonly used registers are these. One is program counter, memory address register, instruction register, temporary register, outer register, input register, data register, and the last one is accumulator. These are the most commonly used registers in your system. You no need to worry about what is this PC, what is this MAR, and so and so. In the next classes, we'll discuss about PC, about MAR, and we'll discuss about each and every register. In this class, I'm just explaining you what is what. In further, in detail, we'll discuss in the next classes, right? Don't worry about this. Just what are the registers that present, I am telling. These are the main registers that may present in your system, right? So here, memory address register, PC, like that, all the registers will be present. Along with the registers, control unit will be there, and ALU will be there in your CPU. This is your CPU component, right? Now, here I already told you that register is a storage device. Storage device means it requires some space to hold the data. So, to hold all these register, how much of memory space is required is this. 4096 by 16 bits of data is required. 096 by required. These are the different types of registers in the system. Now, coming to the definition, coming to the representation. Now, generally computers are, the registers are from your side. Yeah, those are my ways. Generally, computers are with there are only ways to the memory address register will use capital M, capital A, capital R. The capital letters are used to name the registers. Okay? Memory address register. In the same way, COA and register capital are used like this. Next, okay, let me check once. Hello, is it audible? It's mommy. Is audible? One second. Hello. Hello. So some here R1 is the name of a register. You may not. Sometimes you'll use the capital letter. Only the capital letters will be used to represent the register. You can also use a combination of capital letter. You can also use ND letters, or you can use the combination of letters and numbers. Right? Next. Right? So here R1 registers are represented rectangles with representing a register R1. Representing a register R. So the register of size register R2 of size 16 bits. Right? Always remember that the size when you want to mention the size of a register is to be specified starting from 0 of 16 bits register. Then you should mention or you should specify its size from 15 and you should give the starting value that is 0 from the right hand side. So specify the size from right hand side to your left hand side. Here this is my register R2 which is of size 16 bit. So mention the size as 0 to 15 from RHS side to L1 printing the register diagram. The bits of a register. Bits of a register separately. Assume that you have a register. So the range of that register is from zero to 7 bits, right? Individual and zero so 7 16 bits, then The subfields can be specified like this. The PC lower bits are from 0 to 7. The higher order bits of PC are from 8 to 15. At the time of we'll discuss this program counter, we'll discuss what is this lower bits and higher order bits. One second. Discuss after this register transfer. Next, coming to this micro operation. I already told you that whenever you want to execute any instruction, and at present if you want to execute any instruction, something like C equal to A plus B, you will retrieve the values of A and B from the register, right? And whenever you are executing any register, ఇప్పుడు వినిపిస్తుందా? ఓకే, right? Micro operation. So whenever you are executing an operation, transfer Okay, you will give a less than symbol followed by a hyphen. That is the give the results R2. It means that R1's data is transferred to R2. Right? Here you can transfer the data always the side to LHSS. At the when you are representing the size, when you want to specify the size of a register, also you will specify the size from RHS side to the LHS side. In the same way, here also the register transfer always happens to R1 data. Because the complete content of R1 will be moved to R2. This is the representation of register transfer language. Here, so this arrow mark is used to represent the transfer of information. Whenever you want to specify more than one register transfer, you will use a comma symbol, right? You will use a comma symbol to specify more than one register transfer. R1's data is moved to R2, comma R2 data is moved to R1. That means swapping of R1 and R2's data, right? Here some will use parenthesis symbols when you want to specify a register. You will use the parenthesis symbol. These are the ways of representing the registers and the register transfer languages. Next is control function. Register transfer with control function. In the beginning, I told you that your CPU is having mainly three components. One is the control unit, ALU, and the different types of register. Now the control unit is, assume that when you want to perform any operation, always there should be a predetermined condition to be satisfied. Something like, assume that if then statement. Then only you will perform whatever is followed after then, right? If that condition has to be satisfied, otherwise you will not perform whatever is there in the then after then state, right? So here, why this control unit is responsible is, control unit is responsible to perform, when to perform, the control unit will decide when to perform the register transfer from one to the other register. When to perform register transfer data, that is responsible by control unit. So this control unit will have a control variable. The control unit will have a control variable, that is P. It is represented with P, and this control variable is a Boolean variable. That means it may either take 0 or condition is satisfied. Here the condition is satisfied means the value of P should be equivalent to this condition is satisfied, then only. For example, if I write P equal to 1, then R1 to R2. Whenever the value of P is equal to 1, then only R1's data, this P as a control variable, which takes a Boolean, which takes either 1 or 0. Whenever it is 1, the transfer will happen. You will represent this as P colon R2 R1. You will not, whenever I say P colon, by default the value of P is equal to 1. You will not represent like if P equal to 1, then R2 to R1. You will not represent in this computer organization. We will represent P colon R2 to R1 or R1 to R2. That means whenever P equal to 1, then only transfer will happen. Right? So here, see this example. Here we have a control circuit, which is control unit or control circuit, which is of P, a value of P, and this is given as a input to the load input of R2, load content. That is what load operation is. Load operation means R2 is loaded or what is ready to be loaded. This P equal to 1 is given as a input to this load operation of R2. Now R2 is ready to accept the data. What is to be performed? What is to be performed of R1 into R2? Right? So complete this n represent all the n are moved to the register R2. When you represent this with a timing diagram, he assume that here we have different clock pulses, and this is the means load to content. This load value means there is nothing to be loaded into R2. Whenever this load value is equivalent is nothing, that means the value of P is equal to 0. Control circuit is not sending any signals for transfer of data from one register to another register. One second. Whenever this value at clock pulse t, at time t, whenever the value of P becomes 1, then high signals will be sent to the load input. High signals will be sent by this control circuit to this load input of R2. Right? Now here this represent high signals were sent. Next, whenever this is high, it means the value of P here in this range, the value of P is equivalent to 1. Whenever the value of P is equal to 1, next then transfer can happen. R1 can move its data to R2. Next, in the immediate clock pulse, that is at t plus 1th time, 1 second, this signal of load is low, becoming low, then this transfer will happen. Don't think that whenever this load input is high, this transfer will occur. The transfer will occur whenever these signals are becoming low. The signals are becoming low means what? Here the value of P is equal to 1, and after that whenever the value of P is equal to 1, R1 comes to know that R2 is ready to accept the data and it will start transferring its data at this time. R1 comes to know that R2 is ready to accept the data, and it at this point it will start transferring the data. Whenever it is transferring the data, the value of P will becomes 0. That means assume that if it continuously becomes high, then continuously data will be transferred from R1 to R2. This data transfer will be continuous process. That is the reason in the next clock pulse the value of P should be equivalent to 0. Therefore, no transfer will happen. Right? Here see this point. P may go back to 0 at T plus 1. Otherwise, the transfer will occur with every clock pulse transition, because P is remains 1. P remains 1. That is the reason equivalent to types of micro operations. Different types of micro operations were resistors, arithmetic, with all these types of micro operation in the next class in detail. So register transfer micro operation means it transfers the member to the another of other comes under operation. You is the register. So when you are performing arithmetic operations on the data on register, we'll call it as arithmetic micro operations. Next one is logic micro operation. Arithmetic operation performs on numeric data present in the register. Logic micro operations are they performs bit manipulations on non-numeric data present in the registers. And the last type is shift micro operation. Shift micro operation is it just perform shifting of data. That means position of data will be changed. You don't worry, we'll discuss about all this in detail, right? So register transfer, first one, what it will do, it will transfer the content from one register to another register. Second one is arithmetic is performing arithmetic operations on the numeric data. Bit manipulation, third one is performing bit manipulation on non-numeric data, and the last one is read of the data bits present in the registers. I am ending my session today. If you have any doubts, you can ask me in the chat box. Okay, some of you asked me to explain from the beginning. I'll tell you what is a register and everything. So register. Register is a storage device. We have different storage devices like registers, memory, hard disk, and so on. One of the storage device is register, but it is a temporary storage device. It is a temporary storage device. Right? So when the data permanently will be stored in the hard disk, that is in your secondary storage device. Whenever you require the data, only some of the data will be placed in the main memory. The complete data will be there in the hard disk. Some data will be placed in your main memory. From the main memory, you will move the data into the cache memory. When do we move into the cache memory? That we'll see later. Next, from the cache memory, whenever it is required, you will move the data into the register. Right? So the registers are the temporary storage devices that is present in your processor. So from the main memory, data will be moved to cache. From cache, it will be moved to your register. Now, to perform any instruction, CPU, to perform an instruction at present, CPU will retrieve the data from the registers. CPU will retrieve the data from the register. So, your CPU mainly contains three components. One is ALU, control unit, and different types of register. What are those different type of register? They are this. These are the different type of registers present in your system. Program counter, outer register, input register, data register, and the last one is accumulator. ASU is accumulator. So the registers are the storage component. That means register also needs some space. Right? So how much of memory space is required to store all these register? You require 4096 by 16 bits of memory space to hold all these registers. Generally, when you want to represent when you want to represent or when you want to name be represented using a capital letters. Generally the registers are represented using a capital letters. Something like memory address register. If you want to represent this memory address register, you will use the capital letters MAR. Program counter, capital P, capital C, and so on. So diagrammatically, when you want to represent the register, you will use a rectangular box. You will use a rectangular box to represent it diagrammatically. See register, you can use the time numbers, but the letter should be the capital one. That should be capital letter. And when you are representing diagrammatically the registers, if you are representing diagrammatically, you can also specify the size of a register, and the size is also always mentioned, specified from RHS side of the rectangular box to LHS side of the rectangular box.